Taiwan is a crucial semiconductor technology base in the world. Based on the total revenue of semiconductor corporations, foundries, and IC packaging, testing companies in Taiwan are both ranked as the #1 worldwide. IC design is ranked #2, and the memory industry in Taiwan is ranked #4 across the world. The leading companies in the semiconductor industry, such as TSMC and ASE. TSMC is the top 1 foundry, and ASE is top 1 in packaging and testing field in the world. The semiconductor industry in Taiwan has brought in approximately total revenue of 4 trillion NT dollars per year. The contribution of foundries is 1.9 trillion, that of IC design 1.2 trillion, that of IC packaging and testing is 628 billion, and that of memory industry is 294 billion NT dollars. From 1994 to 2021, economic growth has resulted in a 200-fold increase in the semiconductor field. This impressive performance comes from far-sighted policies and the cumulative efforts by academia research teams and industries. The first seed capital for startups was to set up the Semiconductor Laboratory at National Jiao Tong University in 1964. 2 years later, the International Corporation came to Taiwan and built a back-end packaging factory. In 1974, the industry requested the technology adoption strategy. In 1987, the technology-based business model was leveraged and further developed to form the distinctive industries. Taiwan Semiconductor Research Institute is one of the most important contributors to the development of industries. As the industry ran into a technology-based business model, Taiwan government established the National Submicron Device Laboratory in 1988, Chip Implementation Center in 1992, and National Nano Device Laboratory in 2002. In 2003, due to the policy lead, the center was reassigned and directly reported to the National Applied Research Laboratories. Taiwan Semiconductor Research Institute, which provides solutions for comprehensive research, services, and training environment, was named in 2019 for the amalgamation of NDL and CIC. TSRI is expected to be a leading semiconductor R&D center that boosts the cooperative opportunities between advanced academics and cutting-edge technologies. TSRI, T stands for training, S for service, R for R&D, and I for innovation. These items represent the main role of TSRI in the semiconductor industry. Today, a big success and sustainable growth in Taiwan's semiconductor industry are nourished by TSRI. Training. Nurturing technological talents reduces the gap between academics and industry, forming the robust root system of the semiconductor industry. Service. Supporting academia research strengthens the basic academia research, nurturing the industry like providing soil for trees to grow. R&D. Developing research platforms serves continuously novel concepts in the teams of academia and industry, like trunks providing the roots for hydration and nutrition. Innovation. Boosting advanced technologies explores the scaling up opportunities and interfaces the prototypes with commercial applications as prosperous fruits. Hence, TSRI locates near the Yangming Jiao Tong University and Hsinchu Science Park border at the initial investment plan. The perfect location enables the trained talents to be integrated efficiently with industries. TSRI is a developing base for invaluable diversity of experts to exchange views, complete the basic concepts, verify novel ideas, analyze the practical applications, and link with the semiconductor industry. As the bridge between the industry and academia, TSRI serves a comprehensive environment for advanced semiconductor device manufacturing, integrated circuit design, tape-out service, and chip verification services. The past science fiction gradually comes into reality. The demands and imagination are driving forces for continuous technological evolution. Semiconductor industries are maturing over time and turning theories into practice. Facing the expansion of investment in basic research and production environment in Europe, America, Japan, Korea, and China, TSRI will continue cultivating high-quality graduate school talents for domestic academia and industries and being an accelerator in semiconductor research. In the future, Taiwan government commits to promoting 6 national core strategic industries. National Science and Technology Council in Taiwan plans to conduct the projects directly along 6 main developing axes. National Applied Research Laboratories, NARL, to which TSRI belongs, is responsible for developing R&D platforms, supporting academic research, driving forward-looking technologies, and nurturing scientific and technical talents. TSRI is in line with the policy directives of Taiwan government, National Science and Technology Council, and NARL for continuously strengthening the capacity for research and development, nurturing talents, and accelerating the steps for practical applications. The specific acts of TSRI are to identify the constructive and target-oriented research directions by cultivating, improving the service platforms, and prompting the industrial application for future trends. Based on the above-mentioned items, TSRI has established fundamental priorities for future development. TSRI pursues global cutting-edge research. The missions are driving advanced technologies, strengthening the development energy, and offering world-class professional teams. TSRI nurtures talents for reducing the gap between academia and industry. Expanding the sources of talent increases semiconductor industry's competitiveness. TSRI promotes interdisciplinary projects for attaining international standards. In TSRI, the Hsinchu base focus on novel semiconductor devices. Meanwhile, the main mission of the Tainan base is to develop multifunctionality applications. Integrated technological cooperation between these 2 bases benefits the semiconductor foundry service and equipment support. Welcome to Taiwan Semiconductor Research Institute of National Applied Research Laboratories. Based on the regional distribution of semiconductor industries and research groups, Taiwan Semiconductor Research Institute, TSRI, as a semiconductor service center, locates in Hsinchu and Tainan, providing various innovative facilities. The long-term R&D capacities include the operational environment, original equipment manufacture, tape-out service for more than 50 universities, 550 research groups, and 2,200 graduate students. An approximation of 15,000 potential talents attends the courses each year. The Hsinchu base of TSRI locates in Hsinchu Science Park near Yangming Jiao Tong University and Tsinghua University. Including the basement, the Hsinchu base is a 12-floor building owning 23,225 square meters of floor space, including a 3,200 square meter clean room area. The research directions mainly focus on most compound semiconductors, next-generation memories, and the advanced technology of reducing critical dimensions. The Tainan base is adjacent to Chunggong University. This 5-floor building with a basement is 3,312 square meters, including a 660 square meter clean room area. Setting up a P2 biomedical laboratory offers opportunities to explore the knowledge of interdisciplinary research. The 3D packaging, optoelectronic devices, microelectromechanical sensors, and biomedical sensing chip platforms is the mighty strength of developing technologies. To meet the human resources demands for IC design in Taiwan, we introduce indicative software solutions, such as Andes, ARM, Cadence, NVIDIA, Siemens EDA, and Synopsys, supplying more than 15 tap-out services, including transistors, gallium nitride, silicon photonics, and providing EDA tool and computing resources. By supporting of high-level security laboratory and TSRI, research groups in Taiwan could directly utilize the EDA tool and computing environment to design high-performance IC chips and system integration for completing the final products through tape-out service. We expect to enhance the practical experience of academics in IC design by utilizing advanced design tools, cultivating professional talents in semiconductor device manufacturing and design, and replenishing semiconductor energy in Taiwan. Most of the professional master's and doctorate talents of IC design are dividing their research by using the resources and joining the training courses in TSRI. Because of growing demands for artificial intelligence and next-generation semiconductor technology, IC design is increasingly complex. It requires cutting-edge technologies such as big data analysis, deep learning algorithms, hardware IC design implementation, chip verification and measurement, etc. The entry barriers are rising for the developments, which require more human resources, work hours, and budgets. To achieve this purpose, we have established vital technical services, thus allowing academic teams to focus on their specialties of particular chip technology. Research teams could obtain productive results on a timely basis by designing, manufacturing, and testing from one-stop services and tape-out service environments in TSRI. Graduate students could stimulate creative, novel ideas in their studies and enrich the human resources in the IC design field. TSRI owns 3-level clean rooms: Class 10, Class 100, and Class 10,000. The total floor space is 3,860 square meters. There are more than 140 industrial-level types of equipment, including wet clean, lithography, etching, thin film, ion implantation, etc., for developing critical modules of semiconductor manufacturing. A 24-hour available professional factory with security control enables users to proceed the academic and research work in TSRI at any time. For the target mission of talent cultivation in the semiconductor manufacturing field, TSRI constructs key technical modules for next-generation magnetic memory, an 8-inch production line platform of circuit, system, packaging, compound semiconductors production line, and silicon photonics. Regarding next-generation magnetic memory, we are one of the research groups that could deposit uniform multi-layer magnetic films in the nanoscale. International conferences recognize our research results and successful platform. Regarding the 8-inch production line of circuit, systems, packaging, we provide multi-patterning technology for reducing critical dimension by well-controlled accuracy of lithography. The cooperation of post-processing between TSRI and the industry starts from the well-established manufacturing abilities. The outstanding academic fundamental research results could create and verify their own prototype by process integration. In terms of compound semiconductors production line, we are the exclusive provider of wafer-level customized gallium nitride epitaxial process services on 4-inch, 6-inch, and 8-inch substrates in Taiwan. Meanwhile, standardized gallium nitride manufacturing technology for high-frequency and high-power devices serves the research teams in Taiwan to explore the knowledge in the related field. In terms of silicon photonic manufacturing services, we provide high-quality SOI-based passive devices in silicon photonics, including couplers, waveguides, and power splitters. Benefiting the optimal property and flexible process, it catches domestic researchers' attention for high-speed computing, LiDAR, and biomedical sensing. TSRI's electronic measurement laboratories include silicon photonics, power device, nano-device measurement environments, high-frequency, high-speed measurement environments, and micro-electromechanical, electrical measurement environments. In TSRI silicon photonics, power device, nano-device measurement environments provide advanced measurement systems, including silicon photonics optical measurement, high-frequency and high-speed photoelectric measurement, power device measurement, and nano-device measurement. High-frequency and high-speed photoelectric measurement can help with the development of photoelectric components and systems for industries, academia, and research institutes. The power device measurement system exhibits a maximum measurement voltage of 10 kV, supporting both wafer-level and package component testing. Nano-device measurement with a 300mm semi-automated probe station can perform 12-inch wafer auto-mapping tests. High-frequency, high-speed measurement environments can assist industries, academia, and research institutes with the technical development of high-frequency devices, integrated circuits required for wireless communication. For measuring high-frequency devices, various measurement platforms up to 500 GHz have been established. In terms of high-frequency circuit measurement, in addition to standardized high-frequency circuit and antenna measurement services, customized high-frequency circuit measurement services are also provided according to customers' measurement configurations and projects. When it comes to micro-electromechanical, electrical measurement environments, the MEMS system has a complete series of measurement machines, including a white light interferometer and an in-plane vibration analyzer and a laser Doppler vibrometer, etc., to provide a number of micro-electromechanical chip measurement services. TSRI also provides high-quality material testing and analysis services. The material analysis technical service we currently own can be subdivided into 4 categories. 1. Material image analysis technology. Semiconductor components have been reduced to nanoscale dimensions, and material image analysis has become particularly important. In TSRI, an atomic force microscope can measure the surface morphology of 3D nanoimages. The scanning transmission electron microscope and scanning electron microscope can observe material images and perform line spacing measurements. 2. Technology for the composition of materials analysis. Material composition affects the semiconductor manufacturing process and component characteristics. TSRI has an X-ray photoelectronic spectroscope, which can detect the composition of materials in a depth of 10 nanometers from the surface. The secondary ion mass spectrometer can analyze the concentration of elements doped in semiconductor wafers, while the micro-Fourier transform infrared spectrometer and the micro-Raman spectrometer can quickly identify types of materials. 3. Analysis technology for the crystal structure of materials. How to judge the degree of crystallization of a material? X-ray diffraction is a fast identification method. TSRI provides a grazing angle measurement mode that can measure 10 nanoscale crystallization information and evaluate the crystallinity of the epitaxial process. The selected area diffraction pattern obtained from high-resolution transmission electron microscopy can accurately identify the crystal structure on the nanometer scale. 4. The technology for evaluating materials' mechanical and electrical properties. Material, mechanical, and electrical properties are important indicators for evaluating the merits and demerits of materials or components. Our nano indenter is used to evaluate the hardness and modulus of elasticity of thin film materials, thus representing the rigid or plastic properties. The atomic level electrical depth profile is a tool evaluating the carrier concentration, resistivity, mobility, and electrical properties of semiconductor materials after ion implantation. In addition, TSRI has been accredited by the National Certification Foundation, Taiwan Accreditation Foundation, and obtained certification as an ISO 17025 2005 testing laboratory. Thus, the laboratory's testing capabilities have reached international standards and are compatible with the accredited laboratories of 81 certification bodies in 67 countries around the world.